All right, we're ready to get started on our second live lecture this week. It's an odd week, but it was important that we have it today because I need to explain the last really new big fundamental idea that we haven't covered yet. And boy, this one's a doozy because hypothesis tests, they're actually what you're going to see more than anything else whenever statistics comes up. They're usually the first thing that's done, and perhaps and hopefully followed up with a confidence interval and then a sample size, as we're going to be seeing next week. So we want to get clear the fundamental idea behind these so-called hypothesis tests. Now, and of course, we're going to be working with them for 3.5 weeks. And hopefully in that 3.5 weeks, we're going to get you to be really good at them because they're really important. So let's set this aside here. And here's the things we're going to look at. On one side, I'm going to have this. We're going to work through these concepts. But as we do it, I'm also going to be looking at this little template. So looking at this, now here's the basic idea. What the heck is a hypothesis test? Well, a hypothesis is an idea or a belief. And quite often you hear claims being made. And you want to test that claim to see if it's reasonable to be going along with. You only got two choices. Either you go along with the claim or you don't. You disagree with it. And a hypothesis test allows you to test, in other words, see which of the two hypotheses or ideas is the most likely to be true. So you want to go with what's most likely going to be the winning idea. So this little template is very helpful for you when you're first starting hypothesis tests because there's a number of steps, and having a little template will remind you of each step and also hopefully the concepts to run through your head each time you do it. Now, so the idea is someone's made a claim, all right? And one of those is going to be one of the hypotheses. And you've got this first one, H subscript 0, that's your null hypothesis. And the H with a subscript 1 is your alternate hypothesis. And sometimes quite often, instead of a 1, you'll see a capital A there. So perhaps if you continue on in statistics, you'll see the alternative hypothesis with an H with a subscript capital A. So let's talk about, now there's 4 really important concepts I want you to think about whenever you're setting your null hypothesis. And we'll just uncover it here. So these 2 concept questions, are actually these first 3, are about 3 of the possibly the most important ones in the whole course, because these 3 will make sure you understand the basic ideas behind all hypothesis tests. And since hypothesis tests is what we usually always start with, it's kind of a big deal. All right, so first I want you to think, and this will be clarified as we work through some examples, but I want you to think it represents nothing unusual is happening. In other words, it's because you're stating something about a population mean or a population proportion. Someone believes they know what those are equal to. Okay, so perhaps historically the population mean is always equal to this value, and nothing unusual is happening, and it's still the same to this day. Okay, there's no difference between the past and what it currently is. Okay. Or perhaps in manufacturing, there's something that's supposed to be happening. Well, then that would be nothing unusual is happening. Everything's running like it's supposed to. Okay. But that's the basic idea. Now, there's no difference, then that means they're equal. So we always put the equal sign in the null hypothesis. And that's very helpful for you to remember that, because you just automatically know I always put an equal sign in there. And also important is, remember, this is the one that's assumed to be true. It gets the benefit of the doubt. So if you can remember these 4 things, then ask yourself, well, if I don't go with this idea, what other alternative is there? Well, the alternative or alternate hypotheses. And it's just the opposite of these four things. So if you remember these four, it's easy to remember what the opposites are because they're the opposite. Opposite of nothing unusual is happening is something unusual is happening here. Opposite of no difference is there is a difference. Opposite of equals is an inequality. Now we have three different inequalities. Which one you use depends by you carefully reading the problem and seeing which one they're interested in, but it'll be in there. And if the null hypothesis is assumed to be true, has the benefit of the doubt, the burden of proof is on the alternative. Now that's important to remember because, see, a hypothesis test can only support one of these hypotheses. In other words, we're going to use the word except for only one of these, and that one will be the one that has the burden of proof. So when you come to a conclusion, it boils down to just one of two things. Either you found the evidence to support the alternative hypothesis, or you failed to find the evidence to support it. And that's it. That's all a hypothesis test. And you're going to see next week, we'll follow it up with a confidence interval. But it begins with the hypothesis test. Now, I'm going to get back to, well, let's jump to number 39. Nope, too soon. I'm going to kind of work through an example here. We've got this little template here. And when we get to it, then I'll talk about the p-value and whatnot. So let's scoot our little template over here. And let's look at a practice problem here. Now, where did I have that? I thought I had that open. Doesn't appear that I do. Well, that's not very good planning on my part. So let's get down here. And oh yeah, I did have it. It's over here. I forgot. It's on the second page here. Silly me. So don't worry, we got the template being repeated here. Now, for each of the following, you want to fill out these things on your template because these are the important concepts you want to run through your head. And you're familiar with that. That's what we've been doing all term, isn't it? Every exercise, it's applying and thinking about the concepts. Now, this is a repeat of what you did on exam 2, which I'm still grading, by the way. What type of data is this? You always ask yourself that. Now, the first question where you're asking, what are they asking for? Well, you'll notice that they're asking you to test a claim, or they're asking you if there's sufficient evidence to support a particular idea. Well, either you do or you don't. You got a choice between two things. Two things you're going to test which of those two ideas or hypotheses is most likely to be true. In other words, a hypothesis test. Okay. So as you work through all these, see how obviously different this is from anything else you've done. Then you ask yourself, what type of data is it? And are the conditions met? Oh, by the way, you already know how to check the conditions. They're the same ones that you had for confidence intervals. So remember the conditions for when you had quantitative data? Well, that's what it is for hypothesis tests. Remember the conditions for the qualitative or categorical data? Well, it's the same for hypothesis tests. So you know that. Now I'm going to be showing you how to make this sketch. And the good news is this is a really easy sketch to make. Probably one of the easiest ones that you've made all term. Okay. And then, so we're just going to demonstrate all this stuff with this example. Okay, so for starters here, you hear the claim that second graders in their school district are above average in their math skills. Yeah, they're just bragging away. And you're saying, oh, you think so, huh? We'll see about that. And to test this claim, you took a random sample of 60 second graders from their school district, so it should be a good representation of their whole school district, and you gave them a standardized mathematic skills test, to measure their math skills. The sample mean score was 54 with a sample standard deviation of 15. Now, if the nationwide population mean score for this exam that you gave them is 50, is there sufficient evidence to support the claim that was made? Is this 54, this population, the sample mean of 54, is that significantly higher than 50? Or is that just due to sampling error, random chance? Well, that's what the hypothesis test will figure out for you. If this is sufficient evidence to support the claim that this population mean for their school district is significantly higher than the 50, which is the population mean nationwide. All right, so that's the basic idea behind it. Now let's go through the steps here. So we're going to go look at this null hypothesis. And as we do that, what we're going to run through our head are the concepts. Now, first of all, did we ask ourselves what type of data this is? We should have. What are we doing to each observational unit or second grader? Are we putting them into a category, or are we measuring something? We're measuring how smart they are at math. So if we're measuring, then it's all about the population mean. So this symbol that you put here, it's either going to be mu for the population mean, or if it was the categorical or qualitative data, you put a little letter P for the population proportion. It's one or the other. Okay. Now, what was the other thing we remembered about the null? Which symbol does it always have? It always has the equal. So we put that in. No inequalities go in here. Now, so the hypothesized population mean, this value here, that is the 50. And you might be saying, well, how do you know it's the 50? Are you sure it wasn't that 54? That 54 was the sample mean. You never, ever put the sample mean in the hypotheses. Because look, we know what the sample mean is equal to 54. We don't need to hypothesize about that. That's a given. That's a known. What we hypothesize about is what we don't know. Because the null says, look, there's no difference between this school district and the nationwide students. In other words, there's no difference, so their population mean is just 50, just like everybody else's in the nation. There's no difference between this district and the whole nationwide population. Now, for the alternative, this is helpful to remember. Copy down everything except for the equal sign. And that should make sense. Your data didn't change. That symbol would never change. And you always repeat this hypothesized value. That doesn't change. So you never have different numbers there. You never have a different symbol there. Wouldn't make sense otherwise. All you got to figure out then is which of the three inequalities go in here. What is the one they're interested in? So they're claiming that it is above average. It's greater than what the average is for the nationwide, so that it is greater than 50. That is what they're trying to claim. Yeah, we're better than the nationwide. On average, we scored better than 50. Now, the significance level, that'll just be given to us, and we'll see later on how we're going to use this. It's very useful. Now, before I go on, I'm going to make this little sketch here. And this is labeled, now, if the null hypothesis is true, what do we know about the sampling distribution, about all the possible sample means we could ever possibly get from repeated sampling? Well, would this shape be normal? Well, we have a random sample of 60. And what do we know about the sampling distribution for the sample mean? If our sample size is at least 30, it's going to be at least approximately normal. So that's how we know the shape is normal. And what will be in the center of all those sample means? Well, if the null hypothesis is true, the population mean is 50, and 50 would be in the center. So this is what you're going to see about this sketch. If this is the population mean, this right here is the sample mean. If this were the population proportion over here, this would be p hat. And whatever number you have here will be in the center. That's why I'm telling you, it's one of the easiest sketches you're going to make. Now, we're going to revisit this when we get these test statistic and p-value down here later. But before we do that, let me get over here. Let me get my little red pen. Now, look, let's do some what-if scenarios. Now, let's suppose I go and I get a sample mean. Now, we know that sample mean is 54, but you're not absolutely sure where it lands here because these are standard errors, not standard deviations. Okay. So where exactly is 54? Well, we'll find that, but you say, now if my sample mean is, say, just a little bit higher, is that significantly higher? And I think you could just say, well, no, because it's obviously close to 50. I don't even need, it looks like I got a z-score about 0.5. That's not unusual. In other words, if you're just a little bit higher, isn't that just what you would expect to happen if the null hypothesis is true? Yeah, so landing close, that would be like saying nothing unusual is happening here. My sample mean is not unusual. It's just what I'd expect to get if the null hypothesis is true. So if you're landing close to the center, you're going to stick with this idea, the null hypothesis. You'd go with that one. Okay? You got no reason to doubt it. Now let me change the color of my pen. I'll go to purple. Now, but what if instead I landed way up here? Now, would you expect to get a sample mean that far above if this was the distribution of all the sample means you could have centered at 50? Well, you say it could happen, but the probability is really small because the probability would be from that point off to the right. That's a very small sliver. That's a very small probability. So it'd be very unlikely. That small probability says it'd be very unlikely you would get a sample mean that far away if the null hypothesis is true. So what does that mean? You don't think the null hypothesis is true. You would go with the alternative hypothesis if you're far away. Because the farther away you are, the stronger the evidence is to support the alternative. So get the basic idea. Very important. If you land close, that means you're sticking with the null hypothesis. If you're far away, that's evidence to support the alternative. All right, now let me get my little eraser here. We'll get rid of those. I'll get rid of that, and this little dot. There we go. Now you might be wondering, okay, well, sure, Larry, you did really obvious ones where you were obviously, far away or close. That's right, doing obvious ones. But the question you want to know is, well, where do you draw the line? Well, that's what I'm going to show you. That's where the significance level comes in and this p-value we're going to get. Before we can do that, let's go over to our calculator. Now, you know where the good stuff is stashed. That's where you go and you press stat, go over to test. But now the first things you see listed that you've been skipping over, that's what we're going to do now. Now I want you to notice how similar z-test, t-test, one prob z-test, how similar those names are to ones you're familiar with, like z-interval, t-interval, and one prob zn. It's as if you could replace the word int or interval with test, and you have a corresponding hypothesis test. You do. So if it's all the ones with the 2's, set those aside. We're going to get to those later. Okay. So that leaves us with just these 3, z-test, t-test, one prop, z-test. Well, hopefully you recognize one prop proportions. That's for the binary data. Okay. Get that categorical, qualitative with just 2 categories, but we've been calling it binary data. So this is not binary data, so throw that one out. So it's between z-test and t-test, and what you probably learned was you're only supposed to use z-test, the z, like in z-interval, if the population standard deviation is known. And that doesn't happen very often. It happens rarely. I think it might in your first homework for this week, but it's rare. But most of the time you're using t-test. Okay. So with that, and so that's what we're going to use. So before I get in there, let's fill in our little template here. So we want to use t-test, and it's always very helpful, you know, on exams to document what you're using. Hey, are the conditions met? And we'll say yes, because remember the conditions are you have a random sample, got to have that. None of these methods work unless you've got a random sample. And our sample size n was at least 30. So that's what ensured that my sampling distribution is normal. Because this method doesn't work unless the sampling distribution is normal. Now what we're going to do, we're going to go into t-test, and what it's going to do is it's going to take that sample mean and turn it into a test statistic. That's a t-score with the old t-distribution. Works like a z-score. And then once I have that, it'll be easy to locate on here where my sample mean landed. And when I see where it landed, I'm going to ask myself, now what's the probability of getting a test statistic that extreme or more extreme if the null hypothesis is true? And that is what a p-value is. Okay, so let's go ahead and do this. We're going to go over to our calculator. I'm going to press stat, go over to test, and it's t-test. Now let's highlight stats and hit enter. Now the mu subscript 0, I better annotate this just to make sure you're sure about this, because that's a kind of a new symbol. But see the hypothesized population mean? That's what mu subscript 0, sometimes called the null value. This number, this hypothesized population mean, sometimes you hear it called the null value. But it's the value that's in both the hypotheses. We want to know either it's equal to that or our population mean is greater than that. So with that being the case, let's go over here, and our null value is 50. So we enter that. Whoops, I better enter that in correctly. Now, your sample mean. So let's go over here, and what did it say? The sample mean was 54. Now here's a place you got to be very careful. You got a sample mean and your hypothesized population mean. Do not get these mixed up with each other. Otherwise, you've completely messed up your hypothesis test. But here's the simplest way to make sure you did it. I think by now you should be very comfortable with identifying a sample mean. That's the mean that came from your sample, 54, and you should be very comfortable with that being X bar. So you can look at this. Okay, I definitely might not know other things, but I know 54 goes with X bar. And hopefully you should also know the sample standard deviation. You're comfortable with that being 15. And really comfortable with the sample size. That's 60. So you know what the 54, 15, 60 represent, and you can almost deduce, well, the only thing left is the 50. Then hopefully you get comfortable with the idea is, well, yeah, that is the hypothesized value. You know, there is no difference between them. But it's asking you right here, when you see this, it wants to know what number did you put in your hypotheses. Whatever, that same number you had both here is what always goes there. So there's a natural order. That's the first thing they ask, and that's the first number you identify. And then comes the information from your sample. And then it wants to know which of the three inequalities did you do? Well, we did the greater than. So let's go down here. You got to highlight this, and then you got to hit enter to select it. And you might say, well, how did you know it was that one? Well, you see this population mean symbol? That corresponds with this one. And isn't this pointing in the same direction this one is? It is. And remember what this represents. That represents the 50. Oh yeah, I do got 50 there. Press the down arrow. Now this should be highlighted, and this should be highlighted. If so, you highlight calculate, you hit enter. Now I want you to check yourself here. Right below t-test, verify that this looks exactly like what you have here. Because if you've selected the wrong inequality, you've messed up your hypothesis test beyond repair. So check that carefully. Now let's go this t, that's our test statistic. So let's go ahead and write that in, and we're going to put it in our graph. All right, so our test statistic is a positive 2.07 rounding off. So where is that over here? Well, it's like I'm 2.07 standard errors above the center. 1, 2, so that's just a smidgen above, maybe something like that. So let's locate that. It landed right there. So how unusual is that? Well, draw a line there and you shade in away from the center, always away, because that's what tells you what's unusual, by seeing the proportion of the distribution that's that far away or farther, going off to infinity. So you want to know, now what's the probability of getting a test statistic this extreme or more extreme if the null hypothesis is true? And that's what the p-value tells you, and that's right here. Now, unfortunately, it uses this symbol. I wish it didn't, but it does. But what I'm going to insist upon you is that you never ever use this symbol in your work here. You will always write out p-value. If you don't, I'll circle your p and say don't do that anymore. So if you don't want to be told not to do that anymore, then don't do it. Write out p-value. Because it's too confusing. We're going to reserve this symbol to represent the population proportion. Well, and of course, this is quantitative data. There's no population proportions here. So let's put in that p-value. I'm going to write it as a percent, 2.16%. So what that means is this area that I shaded in there, that little area, that's the 2.16. Whoops, I didn't put my percent symbol there. That's terrible. And let's put it over here. Now, what I want you to do, every time you get the p-value, run its interpretation through your head. And having your sketch here helps. So this is the probability of getting a test statistic this extreme or more extreme if the null hypothesis is true. Okay, so that's the answer to the third concept question. Now, when it asks you to define the p-value, well, we just did it, and I want you to define it every single time you get it. So that becomes easier and easier for you to say it correctly. Oh, and by the way, don't stray from that interpretation with something you think that sounds like the same thing to me. Don't do that. Probability is a funny beast. You just stray from it a little bit and it completely changes the meaning. And unless you've had significant training in probability theory, you are not qualified to make the call of saying, sounds like the same thing to me, because, well, you haven't had the training to say that. And if you had the training, you would know better than to say stuff like that. when you're dealing with probability theory. So that's why you can, in the lecture notes and whatnot, you can see how to state it correctly so that you won't be saying it incorrectly and you won't stray from that. Now, let's get over here. So now, here's the idea. I want you to picture. Now, if I had gotten a test statistic that landed close, what would I have shaded in my graph? Well, I would have drawn a line there and shaded it away from the curve. That would have been a big area, wouldn't it? So I would have had a big p-value if I landed close. So a big p-value, well, what do you know about probabilities? What does a big probability mean? Nothing unusual is happening. And which of these two hypotheses said nothing unusual is happening? The null. So it makes sense. If you land close, nothing unusual is happening, and that's what the null says. And also the fact that if you land close, well, that's what you'd expect to happen. The null hypothesis is true. You got the basic idea already, hopefully, that if you land close, you go with the null. And if you land close, you're going to have a big p-value. So that's why we say, compare your p-value to your significance level. This is where we draw the line to know whether we have sufficient evidence to support the alternative hypothesis. We can only support the alternative hypothesis as if we're so far away that this p-value has gotten to be so small that it's smaller than our significance level, or as small or smaller. So in this case, our p-value is, because our p-value is the 2.16%, and 0.05, that's 5%. So 2.16% is less than 5%. So that means we're going to go with the alternative hypothesis. Now, here's how we say that. We actually, even though the alternative hypothesis had the burden of the proof, by golly, we found the evidence, strong enough evidence to support it. So we can use this strong language. We're going to reject the null hypothesis, the idea that it's equal to 50. We're rejecting that. Remember, it had the benefit of the doubt, so we're clearly rejecting it, and we're accepting the alternative. Alternative or alternate hypothesis, because we had sufficient evidence to support it. Then to state it in context, I'm gently introducing this to you in the homework assignments that you have for this week and first half of next week. In fact, I probably should talk about that. So here, let me, I'm going to go ahead and clear this, but you can see all the steps we went through. So we concluded that yes, there was sufficient evidence to support the claim that the second graders in this school district, that their scores are above average, above the national average of 50 in their math skills. And that's all we're saying, is that it's above 50. We're not saying how far above, but that it's above 50, and that's it. That's the limitation of the hypothesis test. If you want to know, well, then what is the population mean if it's not 50? Well, next week you'll see we're going to follow it up with a confidence interval, and that'll give us an estimate of what it is. And we'll contemplate how it agrees with our hypothesis test. Now, let's do this. I'm going to clear off my drawings. Now, your homework for the next 3 homework assignments is quite different. And I have that over here. So going over here to the learning module. So we're getting over here. So modules 21, 22, 23 are quite different. Let's take a look in here. So hopefully this is what you'll be working on, get done this week. our overview and objectives. Yes, yeah, that's all well and good, but it's in the lesson is where all the important stuff is. Now, here's the lecture notes. So be sure and study those. Here's a movie. So be sure and watch that. And now here's what's so different. You're going to get this document here. Let me save that and then open it up. And it's a PDF form file. And what you're going to do is you're going to fill it in. Now, what I recommend you do is, now I just clicked and opened that, but definitely you need to save this to your computer before you start filling anything out. So let me do that here. So go to File, Save As, and make sure you save it to your computer somewhere. Maybe get your name on there. And get it saved, because that always works best. And of course, hopefully you've already got Acrobat Reader, because that's what makes the tutorial DVD work. So you want to be using that. Save your work as you go along. But in theory, you can go in here and you can type. Oh, let me do this. And you do this. Let's make sure that you're able to save your work. So I'm going to do a File, Save, and then I'm going to close this, because you don't want to do all this work and then find out later that you can't save it. So then I'll do File, and then I'll do an Open. Then I look where I had this thing saved. There it is. It's because you put your name in it. You can clearly recognize it. Open it. And I thought I opened it. What did I do? It's not hiding back here, is it? I'm not sure what I just did. Let me try that again. After I get into, so I can close that. Don't need that PDF. I've got this one. Oh. Oh, did I? I renamed the wrong one. I'm so silly. File, Open. Hypothesis test. Oh yeah, I guess I had renamed the wrong one, but you see it's there. And so if you can close it and open it back up and it's saving your work, you know you're good. Now, sometimes I'll have some people who, for whatever reasons, their computer is not saving their work. I don't want you to panic. What you can do, you can go ahead, you could, if you want, you could print this out even, handwrite your work in, and you could just take your cell phone, take a snapshot of each page, but please don't send me each snapshot. Put each snapshot in a separate page in a Word document and send me that one Word document. So don't drive yourself crazy if for some reason the technology isn't working for you. It works for most people, but I always have a few who seem to have troubles. So, and some people don't have trouble, but they don't like to type. They would rather write it in by hand because they find that they learn better that way. And so definitely that's perfectly acceptable. You know, you could print these out, write it in, and then if you had a scanner, you could certainly scan it and send it to me, but most people don't. But everybody has a cell phone where they take a snapshot of each page, put each snapshot on a separate page in a Word document, send that to me. All right? So no need to get stressed out about this. So you're going to be able to type these in, and then down here. Now, if you were writing it in by hand, you could actually draw in your sketch here. But if you're typing it in, you know, there's nothing you can do over here. But this is mostly here to remind you that even if you're not submitting it, that on a piece of scratch paper on the side, you're remembering to make this sketch, because this sketch is very helpful in allowing you to understand what it is you're doing and how hypothesis tests work. So don't overlook them. And by the way, on the final exam, people who make this sketch with their test statistic in there and their p-value shaded in, they're getting a little bit of extra credit for that. So you might want to just get in the habit of doing it anyways, but mostly because it really helps you understand what you're doing. Because in my lecture class, when I'm working with them and a student has a question, they don't quite get it, guess what they all have in common? Either they didn't make the sketch or they didn't do a very good job on their sketch. Okay. So this is a very good predictor of who's going to understand and learn this material and who's going to struggle. So please, it's an easy sketch to make, do a good job on it, and be amazed at how much it helps you. Okay, so the idea is this is what you'll be submitting. But here's what's very, very different. Let me go ahead and close that. Is that what you have is that was the hypothesis test part 1 assignment. Then there's a part 2 and a part 3. Well, for part 1 and part 2, believe this or not, you have the answer key for it. What this does is it allows you to do one and then check your work to make sure you did it correctly. And also, here's the answers, these concept questions, so you can make sure that you're saying these correctly. And as you go down here, that you can interpret your p-value. It's the probability of getting a test statistic this unusual or more unusual if the null hypothesis is true. So you see, this is how you can make sure you're saying and interpreting that correctly and interpreting the test statistic correctly. And ideally, you'll put these in a sketch. Even if you don't submit the sketch, you're making the sketch. Oh, and by the way, this first one, you're actually going to use z-test and probably never ever get to use z-test again, because whenever it's quantitative data, we're always using t-test. But this one, you get to use z-test. All right? So for hypothesis test part 1, hypothesis part 2, you'll be able to check your answers. But with part 3, you don't. You won't have the solutions posted. And so what I do is, and I mentioned this right here, I won't grade all 3 of those until after you submitted hypothesis test part 3, the one that's you don't have the answers to. And then I'll grade and record all 3. But if you only do part 1 and only do part 2 that have the answers and you don't submit part 3, I'm not giving you credit for part 1 and 2, which just you had the answers for them. I want to see if you learned something from those and you're able to do part 3, which doesn't have the solutions. All right, just so you're forewarned. I had one student get all grumpy about that, thinking, what I did part 1, part 2, I deserve the points. And I go, well, you will once you give me part 3, so give me part 3. But anyways, so to prevent any misunderstandings, I try and make it super clear here about that. All right, so let's see here. Oh, I should have pointed out. Oh, that's right. I already got it open. I just need to open it up. So let me get over to the desktop. And that was this one. Notice how this is reminding you. It's a little template. It's actually got the template here. It's stepping you through the process. Because there's a lot of steps to a hypothesis test, or it feels like a lot when you're first learning it. So that's why part 1 is kind of holding you by the hand and leading you through all the steps and all the concepts to think about. And then when you get to part 2, it will prompt you a little less. And then in part 3, you won't have any prompts at all. But also notice this. So like when you're going to state your conclusion, you just check it right here. So it's a very gentle way to teach you how to state the conclusions. You're just being recognized. Oh, so whenever we go with a null hypothesis, I don't say I accept the null. I had to use, it sounds so wishy-washy. I failed to reject the null. And it's important to say it that way because you never say you accept the null hypothesis. And you might wonder, why is that? Well, There's a very good reason, and it's one of the concept questions. And it's what you'll be typing in here. And of course, the solutions are posted, but the idea is this. All a hypothesis test can do is find evidence to support the alternative. So the only one who could possibly get accepted is the alternative hypothesis. And either you accept it or you fail to accept it. And failing to accept it is the same as saying fail to reject the null. So that's how we say it when we choose to stick with the null hypothesis. This is just saying, hey, we got no evidence to reject it. I'm not saying I got evidence to support it. I'm just saying I don't have evidence to refute it. So we're sticking with it. But here, if you did find the evidence to support the alternative, that's when you can use the strong language of accept. And not that wishy-washy word of fail. Now, to state it in context, well, whenever you fail to reject the null, this is how you state it in context. And when you do accept the alternative, this is how you state it in context. So you're just being introduced to this gently. So that's the idea. So think of this, the latter part of this week is your gentle introduction into hypothesis tests, and the whole rest, the next 3 weeks, well, that's all we'll be doing is hypothesis tests, more hypothesis tests. But at the same time, we'll also be pulling in things that we did earlier, like confidence intervals and sample size calculations, just so you can see how they all fit together. All right, well, let's see here. Let's do another one of these. So that was the template that I accidentally renamed. And let's set that aside. Okay, let's look at this one. Oh, and let's get this out of the way. Now, you hear the claim that 87% of high school seniors use text messaging. Well, to test this claim, you took a random sample of 1,800 high school seniors, and you found that 1,584 of them use text messaging. So, do we have sufficient evidence that this proportion or population proportion of all high school seniors using text messaging is different from 87%? And we're going to use a 5% significance level. All right. So we're testing a claim, so we know it's a hypothesis test. Now I need you to tell me what type of data is this. You figure that out while I get my annotation tool ready here. So have you figured it out? That what are we doing to each senior? Well, we're putting them into one of two categories. Either they use text messaging or they don't. It's binary data. Well, it's binary data, and it's all about wondering what is the population proportion. So that's what little p is for. So remember, little p represents the population proportion, and don't you dare use little p for p-value. We put in the equal sign. Now, what are we hypothesizing? Well, they claimed it's 87%. Now, I'm going to enter the decimal because that's how we have to enter it into our calculator. Now, what do we do for the alternative? You say, well, last time we copied down everything but the equal sign. Okay, that's what we're going to do. Copy down everything except for the equal sign. All you got to do is figure out which of those three inequalities. Do all we care about is that it's just less than, or all we care about is just greater than, or do we want to know if it's either less or more? Well, what does the word different from tell you? You want to know if it's different, either significantly more or less. That's when we have the not equal. By the way, of all the three inequalities, this actually is the most common one. Because as a general rule, you would be interested if it was significantly more or significantly less. And that's certainly true here. Now, our significance level is 5%. So that means our p-value has to be this small or smaller before we have sufficient evidence to support this. Now let's run this through our head again. if I land a little above or a little below, isn't that just what you would expect to happen if the null hypothesis were true? It is. So if I land close, oh, and by the way, I better fill these in. Now, if I put a population proportion here, what sampling distribution am I looking at? The sampling distribution for the sample proportion. And what will they all be clustered around if the null hypothesis is true? Well, the null says they'd be clustered around 0.87. So let's put that in. And of course, you'll know that this is normal if n times p times 1 minus p is greater than or equal to 10. Now, you could use p hat. Sometimes I see both ways where they'll use the sample proportion or they use the hypothesized population proportion. I'm not going to get on your case if you use either one. I tend to use p hat, especially if I ended up rejecting this idea. Well, if I rejected this, I don't want to use that. I use my sample. But you could argue, yeah, but maybe you got a bum sample. So, so that's why I'm going to not make a big deal about using one over the other. Now, so once again, if I land close to this 0.87, then I'm going to stick with the null. Got no reason to doubt it. So I'll say that I failed to reject it. We'll stick with it. But if I land either far above or I land far below, well, by golly, I got sufficient evidence to support the alternative. Because if I'm far away, my p-value is going to be so small that it'll be this small or smaller, 5% or less. So that you just ran through your head the big idea. Now let's go ahead and do this. Close that. Oh, let me get rid of this thing. I don't need that there. Cluttering things up here. Now let's go see if we can deduce which TI function to use. So we'll press stat, go over to test. It's the first 6. It's got to be one of these. All the ones with the 2s, throw them out. We're not gotten to those yet. Z-test, T-test, that's for quantitative data. Throw those out. You've only got one thing left. You deduced it has to be 1 prop Z-test. So let's go ahead and write that in here. It's going to be 1. So you see, you don't have to memorize the names. Just recognize them when you see it. 1 prop Z-test. And it's very helpful for you to document in your work, because if I see that and I see that this is set up correctly and you got this sketch, and if somehow you get the wrong values there, I just know you just have to put the numbers in the right places. But I could see that you've learned a lot of concepts, though, that you got to set up correctly. You just got some more fundamental calculator skills to work on. Or maybe you're not remembering what symbols represent what. But with that being the case, let's go over to our calculator, go into 1 prop Z-test. Now, P subscript 0, remember the first thing it asks for is the hypothesized population proportion. So that's our 0.87. So enter it in as decimal. Now what's X and what's N? Well, maybe you don't know what X is, but you definitely know what N is, don't you? It doesn't. You know N is your sample size, for gosh sakes, by now. Well, our random sample was 1,800. So let's put that in. Now, what are we doing to those 1,800? Well, we're going through them and we're counting how many are in this category of interest that use text messaging. And that's what X is. X is the count of how many of the 1,800. And that's exactly what the 1,584 is. So that's right, we had 1,584 out of the 1,800 were in the category of interest. In other words, X divided by N is your sample proportion. Now let's go down here, and now which inequality, the not equal, well, hopefully that one's obvious, highlight it. Now remember, you got to press enter to select it. Now highlight calculate, hit enter. Now let's check this. Now prop, that's your population proportion. Is that what you got here? It is. Now you're going to have to be a little careful here. Now we're going to be okay here, the Z, but you got some P's. You better not get these mixed up with each other. right? But first, let's start with the Z. So our test statistic, Z, is equal to 1.26. That means our sample proportion would, so if you took the 1,584 and divided by 1,800, you know what you would get? 0.88. P, that's your sample proportion. So where is, because this is 87, where's 80.88 on here? Well, that's what their test statistics. It's about 1 1/4 standard error above. So it's right about there. So let's locate it there. So it landed right there. Now, how unusual is that? We'll draw a line there and then shade away from the center, just like we did before. But there's something different when you have a not equals versus what, this is known as a two-sided test. What we did previously was a one-sided test because we only shaded one side because that's all we cared about. But with a two, remember, don't we want to know if we're significantly above or below? So that's why you got to go this distance that you went above. You also got to go that distance below. So you're also going from this point down below. So this area right here is half your p-value. And this over here is the other half. Because you want to know, now how unusual would it be to be this far away from the center, either above or below, to be that far away or farther? So that's what the p-value will tell you. And whenever you have the not equal, you're concerned with both sides. So that's why we got to shade in both. So our p-value, that's this p right here. So it'd be really, really bad if I put p here instead of p-value, because you're saying, what? Well, you said p equals 0.87 here. Why are you saying p is equal to this now? That doesn't make any sense. You're right, it doesn't make sense unless you write out p dash value. So it's 20.71%. That's this area plus this area is a 20.71%. So we can say there's a 20.71% probability of getting a test statistic this far above or that far below or farther away if the null hypothesis is true. Well, does that probability look unusual to you? No, it's big. And look, didn't we land kind of close? Just a little more than one standard error above. That's not so far away, is it? Well, no, it isn't, because that probability is quite big. So our p-value is not small. It's big. How big is it? It's so big, it's bigger than the significance level, because 20.71% is way bigger than 5%. So if you want to, this is decimal format, you can also write as percentage. So, whoops, let's make that, okay, I'm going to erase that. There we go. Let's me write it in correctly here, 5%. So that means we're going to stick with the null hypothesis. So this is what happened. And how do we say that? We say failed to reject. The null hypothesis. Now, of course, in your first homework assignment, you don't actually have to remember that wording. You're being held by the hand so much, you'll be shown those two conclusions, and you just have to recognize it when you see it. Say, oh, that's right. My p-value is big, so that I say fail to reject the null hypothesis. And then, of course, for how to state in context, you'll see the two versions, and you'll be able to recognize, in this case, there is not sufficient evidence to support the alternative. So either there is or there is not evidence to support the alternative. In this case, there was not. Okay, so that's what you'll be doing. So remember, really check your solutions. You could do a few, part of this and then check your work. Like number one, make sure you did it right. And then before going on to the next one. So you can learn from any mistakes as you're going along. And if you're on a roll, you could go ahead and get started on hypothesis test part 2 and get a head start on next week. Nothing wrong with doing that. Okay. All right, so I think that'll be it for this session. So we'll go ahead and we'll see you next week.